Hello class, this is a second video regarding parametric equations and calculus. In the last video we talked about how we could apply the derivative from the calculus into our parametric equations, because by having a pair of parametric equations, eventually you're going to have a path. In here, even the t is 0, you have 1 and 0, and if the t is pi over 2, you have 0 and 1. Therefore, this is your path, which is from 0 to pi over 2. Therefore, the combination of three, they call the level curve, they call the plane curve. But someone said, can I take that path and revolve it around the x-axis and get revolution of solid? Remember, that's a path that every point corresponds to a t value and also correspond to a x and a y. Therefore, there are three variables involved. Unlike in a Cartesian, when you have a curve like y equal to x squared and x was from 0 to 1, you could take that curve and revolve around the x-axis or the y-axis and find the volume of a solid. But in that case, that point right here, it only contain a one order pair, which is x and a y, and I could say the radius is y. But in here, by having three variables and a path revolving around an axis of revolution, doesn't make sense. Therefore, we cannot apply integration into the parametric equations to finding the volumes and to find the volumes of the solid. But someone said, if this is a path, I should be able to know my velocity. That's true, your velocity represented by, at any given point, is represented by a tangent line. And we said that's represented by dy dx. And in the past video, we talked about the derivative, which was dy dt over dx dt. And that would become the derivative of y is a cosine of t, and the derivative of a cosine is negative sine of t, and that's become negative cotangent of t. Therefore, you do know when the t is 0, the slope of a tangent is undefined because you don't have a general limit here. Therefore, I have, in order to find the derivative, my domain has to go from 0 to pi. The end point, I don't have a general limit. Then what happens if I have pi over 6? Therefore, cotangent of pi over 6, and remember, I call the t pi over 6, and cotangent of pi over 6 is going to become radical 3. Therefore, that's the slope of a tangent line. And you see that line is falling line. And the slope is going to be negative. And same thing for all of them, because tangent is positive in the first quadrant. And also I can say, apply the second derivative. Therefore, on the second derivative, you need a pair of parametric equation, and the second derivative, your first derivative, become your new y, which is a negative cotangent of t, and your x stay the same. Therefore, your second derivative of dx squared is equal to partial derivative, derivative of the y, which is the derivative of the first derivative. Derivative of a cotangent is negative cosecant square of t over derivative of cosine. You're going to have same thing as you had on the first derivative, which is negative sine of t. And that answer is going to become negative times negative is a negative times negative is going to be a positive. Positive over a negative is going to become a negative of cosecant squared 1 over sine is a cosecant is cosecant cube of t. Therefore, you know in the first quadrant, the t is always going to be between 0 and power 2. Therefore, that number is going to be a negative and it's going to be concave down. Then maybe someone asked, I should be able to know how long did I travel if this is my path and I move from this house to this house. I should be able to find the distance I travel. This is called the arc length. And how do we find the arc length? Arc length is very important, and I think that's part of the calculus. And you can apply the calculus in parametric equations to finding the arc length. Remember, the arc length is contained of infinitely many line segments. And if you take all these line segments have the same length, all you have to do find the length of one of them. Therefore, this one is x1, y1, and this one is x2, y2. And the distance between 2 points is x2 minus x1 squared plus y2 minus y1 squared. That's the length of one line segment. But if I sum all of it up from t equal to a to t equal to b, therefore, in order to integrate it to sum it up respect to t, I need a dt here as a variable of integration. And I don't have a dt. Therefore, what I'm going to do, I'm going to multiply the top and bottom by dt. And what I really need is only the dt on the top. But I don't need the dt on the bottom. I cannot eliminate it, then you cannot use that dt because you have to eliminate both of them. I'm going to move that dt, and I'm going to move that dt inside the radical. Therefore, when it comes inside the radical, it had to become dt squared. Therefore, the square root of dt squared is dt, that dt is gone. Then something changed inside the radical. Inside the radical is, this is called the sum over that one, that's called a common denominator. I can decompose it. I write x2 minus x1. x2 minus x1 is the change in x squared over dt squared plus, I'm going to decompose this fraction, and y2 minus y1 is dy over dt, dy squared over dt squared dt. Then this is nothing except the derivative of the what? The change in x, that's a derivative of x respect to t, and derivative of the y respect to t. Therefore, that's nothing except the sum of all the line segments when the t go from 0, a to b, and that's the formula for the arc length. Then somebody said, can you apply that formula and solve some problems? I said, yes. I'm going to say my x of t equal to 6t squared and my y of t equal to 2t cubed, and I want my t to go from 1 to 4. Okay, therefore my arc length, somebody said, can I see that path? Well, it is possible, you know, it's not hard. You can, that's your t, that's your x, and that's your y. When t is 1, you get 6 here and you get 2 here. When the t is 2, that you get a 24 here, that you get a 16 here. When t is 3, 9 times 6 is 54, and the 3 cubed is 27 times 2 is 54. And when the t is 4, 16 times 6, 60, 96, and this 216, that's making 432. Therefore, you see, those numbers are a little bit huge, but you have 6 and a 2, 24 and a 16, 54 and a 54, and you see my path is something like that. And I hope, and if it's a 0, 0, I get 0, 0, and that's pretty much my path. And with my orientation, I hope everything I did is right. But you can assume this is right. And I want to know the arc length from t equal to 1 to t equal to 4. Okay, number one, for the arc length, you need dx dt, which is 12t. You need dx dt squared, which is 144t. You need dy dt, which is 6t squared. And you need dy dt squared, which is 36t to the power of 4. Then you have to add these together and take the square root. Therefore, 144, remember I have to square it. That's the square right here. 144t squared plus 36t to the power of 4. Then, if I factor 36t squared, I get 4 of them. 4 plus 4 plus t squared. That's pretty much what I have inside the radical. Right now, what is my arc length? My arc length is from 1 to 4. And when this goes under radical, that 6t come out. 36t squared becomes 6t, and that becomes 4 plus t squared dt. Then, if I want to integrate that one, I call this 4 plus t squared a u, and my du is 2t dt. Therefore, I do need a 2 here, but I'm going to change that 6 to 3 times 2. Therefore, that's 2t and dt become your du, and that become u to the power of 1/2. When I integrate u to the power of 1/2, it becomes u to the power of 3/2. Therefore, u to the power of 3/2, which is 4 plus t squared to the power of 3/2, then I have to divide it by 3/2. Don't forget I have a 3 here, multiply by 3, and this go from 1 to 4. Okay, that's a 2 here, and if I put 4 in here, it become 16 plus 4 is 20. That become 20 to the power of 3/2. And if I put 1 here, that's make it 5. 5 to the power of 3/2. And that number is going to give you the arc length, and you better say the arc length is nothing except a unit. Okay, that's how you find the arc length. But someone said, if you take that path, if you take a path, yes, I cannot revolve it to find the volume. But what happens if I revolve the path and I get a surface of revolution, and I know this is called the arc length, and I already know how to find the arc length. Then if I want to find the surface area, I have to divide this one to infinitely many disks. And if I want to find the surface area is nothing except the surface area like a cylinder, which is 2 pi r times height. Therefore, I need a 2 pi r. And in here, your r is a y. Therefore, if you do it with respect to the x-axis, your radius is the y. But if you do it with respect to the y-axis, your radius is x. Then, what is the surface area of that only and only one disk? Only one disk, the surface area of a change is 2 pi r, but it's part of the arc length. The height is part of the arc length. And I know the formula for arc length. That's the formula for arc length. But what is my r? My r in this case is a y value. You know the arc length is a function of t. Y must be a function of t. In parametric equation, the y is a function of t. Therefore, the surface area is equal to 2 pi from t equal to a to t equal to b. You put y of t if it's respect to x-axis, square root of the arc length, and see everything is in terms of t right here, and easily you can find this surface area. But what happened if somebody said I needed respect t equal to c to t equal to d, and I wanted respect to y-axis? Respect to y, the distance from the curve to the y is x. Therefore, this is respect to y-axis. Everything else is going to be the arc length, dx dt squared plus dy dt squared dt. Okay, I do know the formula for surface area. So far in this book, when we study parametric functions, and parametric functions provide us plane curve, and the plane curve could be linear, could be projectile, or it could be circular. Then we knew how to find the derivative of it. First derivative, second derivative, third derivative. First derivative give you the slope of a tangent line or rate of change, and second derivative give you the concavity. Then we said we also can find the length of the path using the arc length. And then we said if you take the path and revolve it, we cannot find the volume. You have to change it back to Cartesian. But on the surface area, you need a radius, and your radius is either respect to x or y. Could be it is a function of t, and the arc length is a function of t. Therefore, you won't have any issue. Then let's solve a problem right here and say you have x of t is equal to maybe 2t and y of t equal to 3t. And I want my t go from to 1, let me put a 0 here to make it a little bit easier, to 3. You know both of these equations are linear, therefore the graph should be a line, and you know the slope is going to be 3/2 because the slope is 3/2. Therefore, for every 2 unit changes in the x, your y changes 3 units. Somebody said, okay, prove it to me. Here, this is your t, this is your x, this is your y. And if the t is 0, both x and y are 0. But if the t is 1, you have 2 and 3. But when the t is 2, you get 4 and 6. Do you see? When you change 2, you change 3. But when it's a 3, you get 6 and you get a 9. See, you change 3, you change 3, you change 2. Therefore, the rate of change is equal to 3/2. Therefore, I know my path is from 0, 0, 2 to 3, 4 to 6, and 6 to 9. Therefore, this is my path. In here, I can revolve this one about the x-axis and find the surface area. About the x-axis, I take that one about the x, and that point becomes 6 and a -9. And when I revolve it, I get a surface of revolution. My radius here is a y, and your y is 3t. Therefore, your surface area is 2 pi r ds. That surface area is for one of those disks. Your surface area is 2 pi. Your x goes from 0 to 3. Your radius is y. Your y is 3t. And if dx dt is 2, but you got to square it. Dy dt is 3. You got to square it, dt. Remember, this 2 squared is 4, 3 squared is 9, 4 plus 9 is 13. Square root of 13 is not a perfect square. Therefore, you have a 2 here, you have a 3 here, and then you have a square root of 13. 3 times 2 is 6. The square root of 13 pi. All you have left is a t dt from 0 to 3. And when you integrate that one, it becomes 6 square root of 13 pi. It becomes t squared over 2 from 0 to 3. And the answer for that one is nothing except 9 over 2. 9 over 2. But 6 over 2 is 3. You have 3 times 9 is 27. The square root of 13 pi. Unit square, because that's the surface area. This is the end of what we're going to learn about the parametric equation and its application in calculus. Is only going to be the derivative, is only going to be, and then it becomes the arc length, and it's going to be the surface area. Hope you enjoyed it. Hope see you in the next video.